Hi students, welcome now to chapter number 13, section 1. We are talking about periodic motion. You will see videos to talking more about periodic motion, but simply it is when the same motion repeat itself after an equal interval of time, okay? Again and again and again. For example, we have the clock hands. They are always moving, repeat their motion, and also the earth around the sun, and the moon around the earth and around the sun, and sun is rotating around, spinning over around itself, and so on. Any motion repeated itself, it is a periodic motion. In general, we need to deal with sinusoidal functions. We need to represent this periodic motion by sine and cosine function. But let us now look at this wave. This shape is a wave shape. When the wave repeated itself, then we have a new wave. So let us start. This is, for example, xy plane, which is t, and position x of t. X plane and time plane, position versus time, okay? Let us start from t equal to 0. We will see that later in details. We have the starting point at t equal to 0. Then we have starting moving wave. This wave go up and down, and then it goes to 0. Then the wave start again. We have 3 zeros in this wave. This is one, and this is the second, and this is the third. But we need to start from 0 and to end just before the 0, because the other 0, the next 0, belongs to the next wave. So we have each wave has the first 0, the second 0, and the third 0 is not belong to it, because it is for the next wave. So we have this is 0, this is 0, and the third 0 is for the next wave. Okay? These waves are oscillating in time. So in 1 second, we have maybe 1 wave, 2 waves, 3 waves. For example, look at this wave system now, what we have. This is half. This is 1 second, 1.5. How many waves in each second? So we need to count them. 1, 2, 3, 4. Then the first second end, okay? The second one has also 1, 2, 3, 4 waves. So we have 4 waves in a second, in 1 second. Okay? This number of waves in a second is called frequency. So the frequency with f sample is equal to 1 over t, number of times for each second. And its unit is 1 over second, or second to minus 1, or hertz. If you hear this unit in a radio station or something like that, it is hertz. This is the unit of the frequency. Okay? Let us make it easier and solve some example. In a clock motion, we have 3 hands. We have the second hand, which is in pink color. We have minutes hand, which is in light blue color, this one. And we have the hours hand, which is in purple. So these hands are rotating, and they make a periodic motion. What is the period for each hand of them? The period is the time that each hand rotates a total round, which is 600 degrees or 2 pi in radians. Okay, so for the seconds hand, how many time it needs to rotate a full rotation? It is 16 seconds. We know that 1 minute. After 1 minute, it go back. It gets back to its original place. So the frequency is 1 over the time in seconds. Frequency is 1 over 60, because the period is in seconds. T is 60, so the frequency is 1 over 60 hertz for the seconds hand. What about the minutes hand? It rotates once each 60 minutes or 1 hour, and each minute it contains 60 seconds. So in seconds, each 3,600 seconds, the minutes hands rotate a full rotation. So the frequency is 1 over 3,600 hertz. Okay. What about the third one, which is the hour hands? It rotates once each 12 hour. We know that. So we have 12 hours. Each hour is contains 60 minutes. Each minute contains 60 seconds. So this is the convergent coefficient. This is 1 minute. This is over 1 hour. Also, this is over 1 minute. In this case, we can cancel the unit of minute with the unit of minute, the unit of hour with the unit of hour. Then, in each 12 hours, we have 43,200 seconds. So the frequency is 1 over that magnitude of time in unit of hertz. Okay, another example. We have 3 oscillators. Oscillator 1, 2, and 3. One in blue, the second in orange, the third in purple. We see that their oscillations are different between them. The blue one is faster in oscillating than the orange and the slower one, which is slowest one, which is the purple one. Okay, using this coordinate system, this is 1 second, 2 second, 3 second, 4 second, time in seconds, and the position function is x. Okay, we have 3 motions, 1 and 2 and 3. What is the period for each one of them? We need to find what is the time to complete one rotation or one vibration. Look at the blue one. Count 1 wave, 2 waves, then we have 1 second. We have 2 waves in 1 second. So each one wave needs just half a second. This is 1 second, this is half a second. We have a complete blue wave. So the period for the first wave is half second, units in seconds. The second one, which is orange, it has a complete vibration in a second. Look, we have a total wavelength in 1 second. So the period, capital T, which is capital T, is 1 for the orange wave. What about the purple wave? It completes its wave in 2 seconds. Then the period for the purple wave, the third one, is 2. This is the total wave. Okay, what is the frequency for each of them? It is just 1 over T. 1 over T. It is the frequency. 1 over half, it is 2. So for the blue wave, we have two waves in a second. So we have two frequency. What about the second orange wave? We have one wave in a second. So 1 over 1, it's 1, which is the frequency. Okay, we have, look, we have one total purple wave in 2 seconds. So in just 1 second, how many waves we have? We have just half. Look, the upper half. 1 over 2 is a half. So the frequency is proportional to the period inversely. Is that clear? You can solve many like these examples using the table, page number 420, table 13.1. It contains the period and the frequency for each oscillation system. Thank you.